Welcome to Space News Live and welcome Wayne. That chat just popped up. Thank you for joining. So yes, I do this live stream every week. It's where I go over the videos I've posted. So typically that's two videos, dedicated videos on one topic, and then a space news video that just wraps up what's happening in space this week. So 3 videos, but ask me any questions on space related questions. It doesn't matter. I'll go through some of the comments people have left on the videos, and yeah, we'll just go from there. So same format as normal, and yeah, if you can join each week, it's great. I'll watch it later, whatever. So the first video I did this week is on a company called Astral Materials, manufacturing in space. I've known about this company for a while, but I haven't covered it until recently because there's not been a lot of news about it. I've covered a recent company called SpaceForge, which is a UK company that does manufacturing in space, semiconductors and so on. Astral Materials is a US-based company based in California, and they do the same kind of thing. So they're direct competitor to SpaceForge, and they basically are working on silicon semiconductor materials, but very, very pure, ultra pure versions of silicon panels and crystals for semiconductors. And they on the website they explain why you'd want to generate them or make this silicon in space, and that is in microgravity. That is, when you're in space, you don't have convection, you don't have sedimentation, you don't have buoyancy, you don't have the materials bouncing off containers. So you basically have none of these effects here. So you can make pure versions of materials. In this case, silicon or gallium nitride, I believe, semiconductor materials. So you get ultra pure versions, which perform better. They work under high power, and yeah, they're in demand by basically defense companies, military, and also commercial companies. So there's definitely a market for this. So you have SpaceForge, and now you have Astral Materials, two companies working on producing ultra pure silicon in space. They've got a number of partnerships. One of them is with SpaceWorks, who are working on capsules. You can see the capsule here. So they have a number of them, like Red 25, Red 50, Red 100. Well, the number is the number of kilos that it can carry. So Red 25 is 25 kilos, so which is about 50 pounds, something like that. So this is the one. This capsule will have the Astral Materials payload, and it will go into orbit. They will manufacture the crystals, and then it will return back to Earth. The parachute will open, and it will land safely, and they'll extract the crystals. That's the plan anyway. So let's see, I've got some more graphics. So this is from the website. You can see that on Earth, you get low quality crystals. They've got defects in them because of gravity and sedimentation. But in space, you can get these ultra pure, high quality crystals due to the lack of gravity. They also mention so I'm taking some of these graphics from a PDF by Jessica Frick, which I believe I put in the video description. So this is before she became the CEO. She did this whole PDF paper on why you manufacture in space. And so some of the graphics you see here are from that PDF. So you've also got like the smaller supply chain. If you manufacture in space, you just launch into space, generate the materials, and then land back. As opposed to, this is what the supply chain looks like otherwise. You've got all kinds of different companies in different countries, and you've got to move things around, and it's very complicated. And of course, also you've got like national security considerations. So yeah, you can just do it in space, and it's a lot simpler. I think I may have this video that explains or shows. Yeah, this is how they actually use the crystals, how they produce the crystals. It's using a crystal growth furnace, and you have these arc welds. Yeah, you can play it again. And it's basically, this is how they produce the crystals. So they're going to have something like this in space, a very compact version, about the size of a mini fridge. And yeah, you could actually generate silicon and gallium using this method, I believe. So oh yes, I have this graphic. This graphic I didn't put into the video for whatever reason. I didn't get around to it. But you can see I would class Astral Materials as an ISAM startup. ISAM means in space assembly and manufacturing. So it's one of those companies that their business is in space. They don't have rockets, not going to space. They're just manufacturing in space. So you got Astral Materials, you got Space Forge, which is the direct competitor, and then you got other companies like Yuri, Redwire that are doing biotech or pharmaceuticals in space. Vada Space is pharmaceuticals, and then you got this Japanese company, Advanced Optical Materials. But you have a number of companies that have microgravity payloads. Normally they'd be on the International Space Station, but now with Vada Space, you can generate pharmaceuticals using their capsule, and soon you'll have Astral Materials. Space Forge has had Forge Star 1 in space recently. I think it launched this year, and Forge Star 2 is being built at the moment. So you're going to have a lot more activities in space. So those are the ISAM startups. And the number of re-entry vehicles, you've got Vada Space, Atmos Space Cargo, which I did a video on, German space startup. Intuitive Machines are working on a space return or re-entry capsule. SpaceWorks is partnering with Astral Materials. Dream Chaser vehicle from Sierra Space. And there's rumors that Starship is working on a microgravity capability for Starship. That's called Project Starfall. And then you could have the space stations. You could put your experiments on the International Space Station, and that's what companies have been doing for the last 20 years. But soon you will have Vast Space Haven 1, which is launching in May 2026. So not too long from now. And then Starlab, Orbital Reef, and Axiom Station. So Alfredo is saying, can you do a video on all the space companies competing for or in the running to win Golden Dome contract? Yeah, I mean, that's one of my ideas for a video, is to go over Golden Dome. I think that would be quite a long video, because I think every single company who manufactures spacecraft or satellites would want a Golden Dome contract. It's $175 billion over the next 3 years. So there's just a huge amount of money. So I think that would be just about every company. Or every company is going to be Golden Dome ready. You're going to see it in all the marketing for space startups now that, they support Golden Dome. But yeah, I mean, that would be a good idea for a video. And on the funding side for Astral Materials, you've got NASA, who are funding Astral Materials, and you've got UK Space Agency that's funding the competitor, which is Space Forge. ESA is also funding Space Forge. NATO Innovation Fund is also funding Space Forge. But basically, you can see there's quite a bit of funding money available for manufacturing materials in space, especially semiconductor materials. So Astral Materials definitely has, if they can prove their crystal growth furnace works, there's definitely potential to get funding from space agencies, from the US Department of Defense, the US Space Force, NATO Innovation Fund, and potentially private investors as well. So there's plenty of money, I think, available. So if we could just go on to the comments. So I'll just put myself in the corner here. So Marty the Martian is saying, I believe at this time we are spending too much of our limited space funds on science missions. If we grow and improve in space manufacturing, construction and commercialization, we will then have the ability to do more science in space. Imagine a space telescope that was made in space. It would not have to fit in a fairing and would not have to be shaken to bits during launch. It could be huge. So yeah, this is the whole ISEM concept, which is in space assembly and manufacturing. So you've got Astral Materials and Space Forge on the manufacturing, plus also you've got the biotech, you've got Redwire, you've got other companies, and then you've got the assembly side, which is companies that are working on solar power satellites, space-based solar power. They need to manufacture structural trusses, which have to be hundreds of meters or kilometers in length to fit all the solar panels on. And for very large space stations, you need to do assembly in space. So there's a few companies working on that. I've covered Think Orbital, which basically assembles large structures in space. I covered Space Solar a few weeks ago, and they're working on a structural truss, which is hundreds of meters in length. And they've recently verified their robot can assemble the structural truss. So we're getting there. A few companies are working on that. But yeah, we definitely need to do more assembly in space. And Crisis ZU3JQ says, I would like the video, in addition to reproducing the press reports, to include some critical questions or opinions, such as in the case the risk of launch failures and subsequent collisions in orbit that would spread radioactive material to Earth. So I think this question is more to do with my previous video on RTGs, or radioisotope thermoelectric generators, which use radioactive materials to generate power. So obviously, if you're launching them into space, if there's a failure on the launch, you get radioactive materials in the atmosphere. So obviously, you have to be certified to launch, especially with radioactive materials. There's extra steps you have to do. But the amount of radioactive material is quite low, and it's not plutonium-238. In the case of Xeno power, it would be strontium-90. The half-life is much smaller. The quantities are quite low, and so I think the risk to people on the ground is a lot less. Plus, when you launch, the rocket launches usually over water for safety reasons. So if there was a failure, it would end up in the Pacific Ocean or the Atlantic Ocean. So I don't think the risk is great at the moment in terms of radioactive material. And yeah, if I just remove myself a moment for the last question. So the last question is, good stuff. I appreciate the overview of other relevant companies at the end. Makes it easier to stay up to date in the increasingly crowded space startup sector. So yeah, I included a competitors section. I want to do that going forward for when I'm talking about a specific company. I mean, not for lunar design things, but basically when I'm talking about a company, I think it makes sense to have competitors, companies they can cooperate with, partner with, team with, funding sources, maybe supply chain. So you get an overall picture. You get the whole ecosphere. Because a space startup on its own can't do much. It needs to partner with companies. It needs to supply components from other companies. So it gives you a more holistic view of that company. So I think that would be useful going forward. And I certainly plan to do that. So with that, I can move on to the second video this week. And this video has got a lot of comments. I think it's 18 comments so far. So the idea is to make a habitat on the moon. Just take an existing crater and cap it. Put a cap on top and pressurize inside, and you've got an instant habitat. that's the idea, and it's based on a paper I saw. Here's the paper from Scientific Reports: Concept and Preliminary Structural Analysis of a Crater Covering Dome for Future Lunar Habitats. So, oh yeah, Wayne has to leave. Doug wants another walk. So, okay, thanks for joining, Wayne. So, yes, so cap a crater. So, the idea is you can use lunar materials. So, in the paper, they make a geopolymer, which is like a long chain compound, but not based on organic materials like polyethylene, not standard polymer. Geopolymer is made of inorganic materials. In particular, it's made of silicon and aluminium. If you look at the composition of the moon, you can see it's nearly half silicon dioxide, and then you've got another 24% that's aluminium oxide. So 2/3 of the moon is basically compounds of silicon and aluminium, and if you combine those in a long chain geopolymer, you can create something that's similar to concrete. It has the same mechanical properties of concrete. It's quite strong, it's tough, and you can use it as a construction material. In fact, I have this graphic here from the report, and you can see this is the material they made, and they looked at it under a microscope and so on. It's quite tough, and you can make it from moon materials. So this is what the concept looks like. It's basically you find a suitable crater, and an example, this one is 17 meters in diameter, 6 meters in depth, and if you cap it, you'd have an internal volume of about 567 cubic meters. There's a bit of a dip here, a 1 meter dip. So in total, it's 567 cubic meters, which is more than half the volume of the International Space Station. And I have this graphic here as well. And if I remove myself, you can see it's much larger than the multi-purpose habitat, which is what will be used for the Artemis base camp. It's 10 times the internal volume, and it's about half, slightly over half the volume of the International Space Station, which is pretty good. This is just a standard crater. You find a crater of this size everywhere, basically. And all you need to do is put a cap on it, manufacture a cap, and pressurize the internal area. So that's the idea. And from the paper, they used various different kinds of caps. You can use a flat one. This is C. This is flat. You can use concave, where it dips. So they used 1/2 meter dip and 1 meter dip, or convex, where it's curved like a hill. Again, 1/2 meter, 1 meter. So they tested all different shapes, and it turns out the best shape is shape A, that is concave, like the inside of a bowl. And if I bring myself up here, so it's concave like the inside of a bowl with a 1 meter dip, and that has the best strength. And basically, the air pushing up compresses the material, but the material is quite strong when it's compressed, and it can handle 1 atmosphere of Earth atmospheric pressure, no problem. It's about 55% of the maximum stress, so it's very safe. This version A here. So yeah, that's how you cap a crater, and yeah, you've got a habitat which is quite big. And the advantage of this method is you'll find craters everywhere on the moon, so you're much more likely to find a crater near a prime spot than, for instance, a lava tube. Lava tubes are much harder to find in a good location, and the other problem is they tend to be quite deep, 80 to 100 meters deep, in which case you have to use some kind of pulley system, or you have to create a slope all the way down. So a crater, for instance, this is 6 meters. So it's not going to be a problem working with this crater. And you could tunnel into the side of the crater and add an airlock, for instance. So yeah, they're easy to work with, the lava tubes. They're more common than lava tubes, and they can be quite big, the internal volume. So the only issue is finding a cap that's suitable, but they recommend a geopolymer cap made of materials found on the moon, and it's quite like concrete. So that's their plan. So there's quite a few comments we had on this topic. So Ken Moore 966 is saying, maybe I missed it, but I am a little fuzzy on where the airlock would go for an entrance and exit. Still a great presentation. So I should reply to this saying there is no mention of an airlock in the paper. Excavators could be used to create a slope path to the base of the crater where an airlock could be installed that gives access to the internal pressurized area. And the depth is only 6 meters, so tunneling the side shouldn't be a problem. And Roger Pan NZ, New Zealand, said, since it needs a tough liner anyway, seems like you would be best just to put an inflatable habitat inside and keep the crater unpressurized. Refined construction like airlock seems difficult. The place is so dusty, why not use the concrete for the floor also? I mean, that's an alternative. If you can make the geopolymer, could you not just put it on the floor? So the issue with the geopolymer is that they didn't study whether it allows gas to permeate through. If it doesn't, if it blocks the gas, maybe you don't need a liner. I don't know, but it wasn't tested. So for safety reasons, you'd use an internal liner, so there's no outgassing. But more study on that material, or maybe it could be made to be not permeable to gases. But yeah, you could just put an inflatable inside, in which case you don't need to pressurize it. You just use the inflatable habitats. Yeah, that's an alternative as well. And Jim Watchman is saying, finally, someone else is talking about capping a crater to seal and pressurize. Oh, and add oxygen so we can breathe. Yes, I know I told you about the mile-wide craters that we can build cities in, but it all starts small. I was surprised when the first page I found was back in 2022. I may have been commenting about this earlier, 22, 23, 24, mega cities in craters. We should build a city in a lava tube so we can expand the housing throughout the tube, so we don't need to cap a new crater to expand. So, so I guess he's saying there's not really a lot of people have not really talked about capping a crater before. I just saw this paper about a week ago, and it seemed interesting, so I thought I'd do a video on it. Yeah, so it's definitely worth throwing that idea out, and maybe it can work. Yeah, so there are some more comments as well on this topic. So let's see. It's this one here I want. This one. Remove. Add this one here. Okay, yeah. So Wingsley is saying. So Wingsley asked quite a few questions. I'm just going to answer some of them. So he said, would the ISRU equipment on site be useful in digging a tunnel out of the side of the crater wall in order to install an airlock? If so, installing airlocks would be straightforward matter. So I dug up this NASA report, scientific report, or engineering report, and you can see in this graphic, you can see they've tunneled into the side of a hill, and they've installed airlocks on both sides. Airlock here, airlock there, and tunneling. So like NASA certainly looked into having a base underground and tunneling into the sides and adding airlocks. So this is definitely something you can do. NASA's looked at it, and I think for a small crater where it's only depth of 6 meters, I don't think it's a big issue. I think it's perfectly possible to do this. And he also goes on to say, Sierra Space has already indicated that their Life Inflatable Habitat module could be up to 5,000 cubic meters in interior volume, so providing a useful habitat to fill a small crater should not be a problem. That's true, and Sierra Space is working on its inflatable technology. That could be for a commercial space station, but it also works on the moon. And in fact, they've got a contract with NASA to see whether their inflatable habitat technology would work on the moon. So they're already working with NASA on the inflatable habitats for the moon, and that would be perfect for the crater. You could put one of their very large inflatable modules in the crater, then pressurize it, then put the cap on, and then you've got habitat. And what else? He says, number 8, the intriguing possibility that I would see would be to combine the concepts of the cap crater with the notion of Haven Lunar Base to provide a larger capped crater base with the concept of windows for lunar visibility. Yeah, the issue I was wondering with when I did the video is there's no sunlight. The cap covers the entire top and it would be complete darkness. Obviously you'd have internal lighting, but you'd feel very confined. A lot of the lunar bases have some kind of special window module or cupola, such as the Haven module. So you do see in this NASA concept, they have this idea of sunlight and they call it light wells. I was wondering whether you could tunnel into the side of the crater with a light well. Yeah, I don't know. But definitely having some kind of light or access to the surface, I mean, from a mental health point of view, would be very beneficial. But yeah, it's definitely a question. How do you funnel light into the base? And Agra Farm Slick is saying, I think a hybrid setup using both Sierra Space's Haven concept and what is described in this paper with some modifications would make an ideal initial setup. So basically, it's a hybrid, just like Wingsley is saying. It's some kind of hybrid between inflatable habitats that could be just lowered into the crater, and then you could cap it, for instance. Yeah, there's no reason you couldn't do that instead. So yeah, I mean, one concept is you use pressurized internal in the crater once it's capped with a liner, or you could just drop in an inflatable habitat. And Einzig Freya name is saying, a lot is talked about the ideal shape of the cap, but how exactly would you actually build it on the moon? So I think the way they do that, assuming it's like concrete, and they say mechanically it's the same as concrete, you basically use solar furnaces to heat the to basically generate the aluminium and silicon from the lunar material. You add your chemical additives and binders, use solar furnaces to melt this, and once it's melted, it's quite fluid, just like cement. And then you pour it into the shape, and then you let it cure for 28 days. It just sits on the moon for 28 days, and then it solidifies into a solid cap that has the right shape. And then you just have to lift it and move it on top of the crater and drop it onto the crater. That's my understanding. Yes. So it's a question of like you need sieves, you need solar furnaces, you need chemical agents, binders, additives, and you'd need the autonomous robots to move the cap. Yeah. So that's my understanding of how it works. And I think there's another question here. Consider the regular 5+ scale lunar quakes when designing habitats. Yeah, I mean, lunar quakes is an issue, but that's an issue for every habitat you build on the moon, right? Whatever your habitat is, it has to handle lunar quakes. So yeah, that's something that has to be taken into consideration. I'm sure NASA's aware about lunar quakes. Yes, because they were measured, I think, by Apollo in the 70s. So it's a well-known issue. And then I moved on to, if I look at this, my last video of the week, which is the Space Startup News. And I covered Redwire. I covered this new capsule from a Croatian startup. And then I just remove myself. Then I covered Rocket Lab's new launch pad, which is going to be activated very, very soon. I think the official opening is next month. So first of all, Redwire, which maybe you're not aware of. I mean, it's not well known, I think, in the space sector compared to, like SpaceX or Blue Origin. Not many people know about Redwire, but it is very important in the space sector. They work with a lot of companies. They work with NASA. You can see here they're building machines and robots to build infrastructure, berms, landing pads, roads, not just for Mars, but on the moon. They're working with NASA and ESA. This is the Lunar Gateway, and you can see in red, this is the IHAB that the ESA are building. And the docking ports are being made by Redwire. I believe they're also working on these rollout solar arrays, these giant solar arrays, which generate, I think, a lot of solar power. I think it's in the kilowatt range, tens of kilowatts. These are from Redwire. They also do the rollout solar arrays on the International Space Station. So yeah, they're very active in space. They worked with Firefly for the Blue Ghost lunar lander. So yeah, my first segment was on Redwire, and yeah, they're also working on the SkimSat, this kind of very low Earth orbit satellite, which is better for imaging because it's lower. It basically orbits at a lower orbit. And my second segment was on this brand new startup that is a Croatian company working on a microgravity spacecraft. They already do microgravity payloads, but now they're building their own spacecraft. So it goes into space, you spend 3 to 6 months, and the payloads generate whatever materials, pharmaceuticals, and then it returns back to Earth, lands, and you retrieve your materials. So, yeah. And here I have, if I can bring it up, I have a video of, yeah, this is the ROSA rollout solar arrays from Redwire. As you can see, these are giant arrays. These will be for the gateway. So there'll be 4 of these, and that generate, I think, 60 kilowatts of solar power. Basically, a huge amount of solar power has been generated. So anyway, that's Redwire. And this is, let me bring this up, this is the capsule from this new company, Croatian company. And yeah, they got 300,000 euros in seed funding. And yeah, I think 2027 is the first year that they will actually launch a subscale version. And they basically iterate from there. They'll basically keep launching and verifying and validating until it gets to its full size. So they're moving fast. They already, yes, and Marcos is saying, vamos, que vamos, let's go. So yeah, this is another European company that's working on reusable capsules. The other one is the Exploration Company. That is a very well-funded European company. They just do capsules. They're working on the Nix capsule. They're funded, I think, 400 million euros. So 1,000 times the funding level of this company. But yeah, that's 2 European space startups working on capsules, which is awesome. So remove that there. So yeah, that's the second segment. And obviously I'll keep you up to date on their progress. And the third segment was Rocket Lab. This is their launch pad at Wallops Island in Virginia. And you can see actually on the pad is the Neutron vehicle. This is their medium lift vehicle. It can lift 13 tons into low Earth orbit, and it's fully reusable, as in 100%. The first stage comes back and lands, and the second stage always stays attached to the first stage. It basically opens, it just opens like that. The payload is released, and then it closes back up, and then the whole vehicle comes back down and lands. So it's 100% reusable, high cadence vehicle, and it'll be launching later this year. It should be launching in 2025. So as you can see, the pad is practically built. There you can see the launch pad. You've got the flame diverter there. You've got the fuel tanks. You've got the water tower. It looks pretty much done. They're just certifying and verifying all the systems. The flight hardware is built, and you can see it on the launch pad. And they're very, very close to officially activating the launch pad, as they say. Here's Wallops Island. You can see it here. This is where Northrop Grumman launches the Antares rocket to the cargo rocket that goes to the International Space Station. And Rocket Lab is also launching from here. And this is where Neutron will launch from. Hopefully later this year at some point. Don't know exactly when, but later this year. And we had a comment. We actually had two comments on this. But basically saying, although I had heard Redwire mentioned here before, I did not know they had so much going on. Quite impressive. They are very impressive. They are working on a lot of projects behind the scenes. So I want to start including a kind of a ecosystem section of my videos explaining for any particular startup, yes, that they work with this company, the supply chain is that, the funding is from this one. Because I think you'll find when it comes to supply chains, you'll hear Redwire a lot. Like, for instance, Firefly, Blue Ghost, Lunar Lander. I had no idea Redwire were involved, but all 12 of the cameras and the core avionics came from Redwire. So I think I should probably talk about some of the suppliers when I do my my videos, because yeah, it's not just a particular startup. There's a lot of other companies involved, and also the funding and also the competitors, just so you get a more holistic view of that particular company. And in other space news, if I can bring it up. So Axiom Station's Payload Power and Thermal Module, or PPTM, final weld completed. So this is in Thales Alenia Space in Italy. This is where a lot of modules are fabricated, International Space Station modules, Axiom Station, and so on. So the final weld has been completed, and it will be shipped to Houston in Texas in the following weeks for outfitting and so on. And this is part of Axiom Station, which is a commercial space station. It's already received funding from NASA, and it will be one of the space stations competing for the Commercial LEO Destinations Award Phase 2, which will probably be awarded next year now. You've got Vast Space, you've got Starlab, you've got Orbital Reef, and you've got Axiom. So there's at least 4 companies working on space stations, and NASA will award a certain amount of money. I don't think it's a lot of money, to be honest, but anyway, that's Axiom Station. And on the right, we have Thales Alenia Space, Italy, to build multi-purpose habitat for the moon. So I've covered a lot of lunar base designs, but the actual lunar base that will probably exist on the moon will be Artemis Base Camp, because NASA has the funding. And so this is the habitat you're looking at here. It's called the multi-purpose habitat. It weighs about 15 tons, and it's now, they've got the sign off from the Italian government to start designing and building this habitat. So Marty is saying the small companies you feature won't be small forever. Some are getting quite big. Yeah, I mean, Rocket Lab was small to begin with. I mean, SpaceX was small to begin, right? So there's a lot of these small companies that could in the future be very big. So hopefully I've covered them when they were small. So if you're watching the channel, you know about these companies before they got huge. I mean, Intuitive Machines, they got contracts worth billions of dollars now. And you could go on, right? There's lots of companies that are potentially could get very big. So yeah, so I'm quite very interested in the multi-purpose habitat. Maybe I'll do a video on it because it's this is the beta, NASA Artemis Space Camp will consist of the multi-purpose habitat, and then you'll have the LTVs, the lunar terrain vehicles, which are being built, designed right now, and yeah, you'll have whatever else is involved in the NASA Artemis Space Camp. I should do a video on that because I'm not 100% sure exactly what components, but definitely the multi-purpose habitat is the key critical component because this is a dedicated habitat on the moon, the very first one, and it's now under design and construction. Like the documents have been signed and it's going ahead. So that's very exciting, I think. And I think that is it. I've covered all the stories this week, and so in terms of next week, I've got a few ideas. I'm not really 100% sure what I'm going to do next week. So yeah. Anyway, next week I'll do 2 dedicated videos on something, and then whatever's happening in space news, because there's always lots happening in space news. There's always more stories to cover. But yeah, thank you for joining, and I'll see you next week.